Okay, so the next section, piecewise functions, is when you have a function or a situation that is made up of multiple functions pieced together to create one giant function. For example, I want to take a look at this. This is not any one function that we have looked at before, but it does consist of three separate parent functions. I'm going to just use this as an example. And I'm going to come up with an equation to represent this piecewise function algebraically. So this function, we're going to call it f. We need to come up with an equation for this function. So first we recognize that it is one function from 0 until 10. And this, I'm going to let you guys know, is a square root function. So I know that it's square root of x from 0 to 10. From 10 to 20, this is mx plus b, it's a line, and then onwards after this point coming down, it is a quadratic. What we want to do now is to create equations for each of these and come up with one piecewise function to represent the whole thing. So I can tell right now the piecewise function is broken into three parts. Right? There would be the first part here, the second part here, and the third part will go here at the bottom. The first equation, it's very straightforward. It is a square root of x function. And it is from 0 till 10. So it's the square root of x when x is greater than or equal to 0, but less than or equal to 10. The second part of this function, this is where it gets a little bit trickier. We know it is y equals x. But what we don't know is the equation for this line. We know it follows mx plus b, but what we still need to find is the equation for this line. We are given, because it's y equals x is the parent function, we know that the slope is 1, but what we still need to find is the y-intercept. The easiest way for now that we're going to do it is we're going to use translations. The original y equals x function goes through here, goes to the origin. We're going to shift it right by 10 and up by 400. So what does that look like? Right by 10 is inside the function, and then up by 400 is outside the function. So it's the y equals x graph, shifted right by 10 and up by 400. And that is the case when x is between 10 and 20. I want you to pay attention here. I put x is less than or equal to 10. So when it's equal to 10, it's a square root function, which means in my second interval, this has to be x is greater than 10. Not greater than or equal to, simply greater than. But less than or equal to 20. Recap. The first part of this graph, or the first part of this function, is the square root function. And that function exists from 0 to 10. It starts at the origin, which is exactly what the square root function is supposed to be. So my equation, the first part is root x when x is between 0 and 10. The second part of this function is a line. It's a line where I know that the slope is 1. If I know the slope is 1, I can see that m would have to be 1, but I don't know what the y-intercept is. So technically, I could go all the way down and try to figure out where the y-intercept would be. But we'll come back to that part in another question that we look at. So in order to find the y-intercept, the easiest thing is to translate your function. From 0, I'm going to go right by 10 and up by 400. Because this is where the y equals x function should be starting, but we're going to pretend it starts here. So right 10, up 400, that's given there. The third function I know is the x squared function. What I don't know is the x squared function. What I don't know about it is where the vertex is. Now again, the regular x squared function has a vertex at 0. This function has a vertex here. Now, so what I'm going to do is shift it to the right by 25. So it becomes x minus 25 squared and go up by 400. So up by 400, and that gives me the vertex. What I still need to, we'll leave that one for later. So that would gives me that function there, and it is between 20 and 25. So greater than 20 but less than or equal to 25, and that's my piecewise function. Starts at 0, ends at 25. I need to create an equation for each piece in this graph. Okay? What we're going to also look at now is how to simplify this equation. It is not necessary. You are perfectly fine to leave it like this, but just in case some of you may be doing it a different way, I do want to show you how this can be converted into mx plus b form. So just remember, x minus 10 plus 400. Because there is no slope outside, we can simply open the brackets. We have x minus 10 plus 400. So y is equal to x minus, x plus 390. So y equals x plus 390 is the same thing as x minus 10 plus 400. We're going to move on to do some questions on my laptop to show you guys how to actually create the same equation using when we have word problems. So in here we had a graph and we turned it into a piecewise function. Now we're going to look at what happens when you have a word problem and you need to make a piecewise function. And then when you have a piecewise function, how do you make a graph out of that? So as promised, we're going to look at some questions where there's a word problem and we need to create a equation out of there. So a city parking lot uses the following rules to calculate parking fees. A flat rate of $5 for any amount of time up to and including the first hour. A flat rate of $12.50 for any amount of time over 1 hour and up to and including 2 hours. A flat rate of $13 plus $3 per hour for each hour after 2 hours. Use a graphical model to represent the function for parking fees and then create an algebraic model. In your beginning questions, in all your examples, for the most part, the way they ask the question is a hint for you to know how to answer the questions when you're doing it yourself. So first, create a graphical model, then create an algebraic model. Meaning, come up with a sketch of the graph first. Once you have the sketch, use it to come up with your equation. So the first thing we know is there's a flat rate of $5 for any amount of time up to and including the first hour. So in the first hour of parking, you're going to be charged $5 per hour. What does that mean? I'm getting a smaller point here. For the first hour, it's $5. No matter how long you stay for, you will be charged $5. Second hour. What we know for the second hour is there's a flat rate of $12.50 for any amount of time over 1 hour and up to and including 2 hours. So the second one is 2 hours. So from 1 to 2, let's say that's 5, that's 10. So here would be $12.50. So from 1 hour up until 2 hours, we're going to get $12.50. Remember, we do not include the 12 at 1 hour. It has to be $5. So this has to be an open circle. And that would be the $12.50 flat rate fee between 1 and 2. Then there's a flat rate of $13 plus $3 an hour for each hour after 2 hours. So after 2 hours, let's get another color going. It is going to be from 2 hours onwards, it's going to be $13, right? Oh, that needs to be an open circle. And it's $13 plus $3 every hour. $3 an hour has a slope, therefore I'm going to make a diagonal line. This is a rough sketch of what's happening. I now need to go ahead and make sure we understand how I came up with this graph and then create a function out of it. Step 1, we know for the first hour from 0 to 1, it is a flat rate of $5. So if I stay for half an hour, $5. 1 hour, $5. 10 minutes, $5. Therefore, there's a horizontal line representing $5 for any amount of time between 0 and 1 hours. Then it says from 1 to 2 hours, it is $12.50 that the person would have to pay. So between 1 hour and 2 hours, it has to be $12.50. keep in mind that if you stay for 1 hour exactly, you are going to get charged $5, not the you're not going to be charged at $12.50. I don't know why I put that there. And then after 2 hours, so for more than 2 hours and up until however long you stay, you're going to get charged $13 plus $3 for every hour that you stay after 2 hours. So if you stay for 1 hour, you're going to be charged $13 plus $3 for that 1 hour, so $16. We have a general graph of what our function would look like. What we need to do now, and I'm going to space this out, is create an equation. All of this equation has 3 separate graphs, so it's going to have 6 different parts. 2, 3, there's 3 equations, and then 3 domains under which the equations exist. The first domain is from 0 to 1. So when x is greater than, well, I mean, technically you won't be equal to 0, but less than or equal to 1. And then for the second domain, it is between 1 and 2. So greater than 1, but less than or equal to 2. And the last one is when x is greater than 2. So the first one is between 0 and 1. The second one is between 1 and 2. And the last one is greater than 2. The first equation is a horizontal line, and horizontal lines have the form of y equals whatever the number is. In this case, it's y equals 5. So I'll put a 5 here. So f at x is 5 as long as x is between 0 and 1. For the second equation, it's a horizontal line which follows y equals $12.50. It's going to be 12.5 as long as x is between 1 and 2. And finally, the last one here, this is an equation. I know the slope is going to be 3 because it's $3 per hour. So I have $3, so y is going to be $3, and I still need to figure out y-intercept. But going back to what I just showed you guys on the board, I'm going to use translations. So normally, this function should be starting at 0, but instead it's starting here. So I'm going to translate it right by 2, so x minus 2, and up by 13. So up by 13. So this equation becomes 3x minus 2 plus 13. And that would be my new function. That would be the piecewise functions representing these 3 conditions. Let's keep going. Number 2, we have to graph the following piecewise function. So it has 2 sections. The first section is x squared when x is less than 2, and 2x plus 3 when x is greater than or equal to 2. So let's start with our Cartesian plane. We know that we're going to have our key point is going to be at x equals 2 because that is when the 2 domains split. X is less than 2 meaning to the left of 2, and then x is greater than or equal to meaning to the right of 2. So that is my key point. So the first function is x squared if x is less than 2. So let's draw x squared. 0, 0, 1, 1, 2, and 4. But at 4, it's an open circle because it's not equal to. Negative 1, 1, negative 2, 4, and it will continue in that direction. So I'm going to create this graph. Remember that it does not go past the 2. The next equation is 2x plus 3 as long as x is greater than or equal to 2. So let's draw 2x plus 3. And there's 4. So we start at 3. We're going to go up 2, right 1, up 2, right 1, and that's where we'll end up here. And then extend the graph using a slope of roughly 2. 2x plus 3 and x squared. And there you have it. You have a general function, a quick sketch of x squared. So this piecewise function of f at x, which is made up of x squared when x is less than 2, and 2x plus 3 when x is greater than or equal to 2. And lastly, we're going to create an algebraic representation of the following piecewise function. So I can see that there are 2 graphs. One is the 1 over x graph, and then there is a horizontal line, which is y equals a number. So let's look at the function that we have. So f at x is equal to, now this one shows that it is 1 over x when x is less than 2. When x is less than 2, it's 1 over x. In fact, the 2 has it shaded in, so it's when x is less than or equal to 2. And the second part is going to be 2, so y equals 2 when x is greater than 2. So to the left of my key point here, the function is 1 over x. To the right, it's y equals a number because it's a horizontal line. So I just put that in my piecewise function form. 1 over x is less than or equal to 2, and 2 when x is greater than 2. And that is how we're going to have to work with piecewise functions. Inshallah, I'll see you guys tomorrow.